Hi, my name is Eugene Lee, and today I'm gonna talk about the design philosophy of the DARPA Internet Protocols. DARPA, the Advanced Research Projects Agency of the U.S. Department of Defense, has developed protocols for packet-switched network like IP and ICP for a long time. In this presentation, I will explain the original objectives of the Internet architecture with the relation between the goals and protocols. The fundamental goal of DARPA Internet architecture is to develop effective techniques for multiplex utilization of existing interconnected networks. For this, packet switching was selected because of its applications being supported. Next, following are detailed set of goals for the establishment of the Internet architecture. First, Internet communication must continue despite loss of networks or gateways. Second, the Internet must support multiple types of communication service. Third, the Internet architecture must accommodate a variety of networks. Fourth, the Internet architecture must permit distributed management of its resources. Fifth, the Internet architecture must be cost-effective. Sixth, the Internet architecture must permit host attachment with a low level of effort. Last, the resources used in the Internet architecture must be accountable. These goals are in order of importance, and the network architecture would be changed if the order changed. Let's look at the first goal. Internet communication must continue despite loss of networks or gateways. This goal is the most important goal on the list of second-level goals about survivability in the face of failure. For this goal, state information which describes the ongoing conversation should be protected. In some structures, state information is saved by replication, but it has several difficulties. Another way is page sharing, which gathers the information at the endpoint of the net. In this way, instead of having state information, it uses stateless packet switches called datagram network. The second goal of the Internet architecture is the Internet must support multiple types of communication service. The traditional service is virtual circuit service, which provides data in bidirection. However, as the range of needed services expands, there were several difficulties to provide using just one protocol. So, it makes the protocol into two layers, TCP and IP. TCP provides the reliable sequence data stream, and IP provides datagram. Let's talk about TCP and datagrams more. TCP has developed through several stages. The original ARPANET host-to-host protocol provides flow control based on both bytes and packets. However, it seems really complex, so it changed to delivery of bytes and have several advantages. For example, with the byte stream, control information could insert into the sequence space of the bytes, and packets could change sizes by break or gathering. However, there were also other problems, So it changed to use both packets and bytes like ARPANET protocols. Next, datagrams. Datagram is the entity which is transported across the underlying networks. Datagrams are important for the Internet architecture. There are several reasons why. First, they eliminate the need for connection state within the intermediate switching nodes. Second, they provide a basic block which various services can be implemented. There are remain 5 goals, and the remaining 5 goals are in lower importance, so they are not complete yet or less effectively met. Until now, we are talking about the goals of the Internet architecture. Then, let's talk about the architecture and implementation. Realization is the term which means a particular set of networks, gateways, and hosts which have been connected together in the context of the Internet architecture. Realization can be deferred by situations. In the context of its priorities, the Internet architecture has been very successful. However, the other goals are not effectively succeeded yet, and new building block better than datagram is needed. Thank you for listening my presentation.